Are you able to see the slide?
Yes, ma'am.
Assembly line balancing rules दिख रहा है?
हाँ, yes, ma'am.
Okay, ठीक है. So let me start with the very first slide. As I told you that directly I am discussing on the numericals. Okay, fine. So we have in module number 5 the numericals belonging to assembly line balancing. Little bit lengthier but very easy, right? So first of all, total let me discuss about the number of methods which we are going to cover up in the assembly line balancing numericals. That are four types. The very first is heuristic approach. The second one is the largest candidate rule. The third one is the Kilbridge-Wester method. And the fourth one is rank position method. Right. So these four methods are covered in your syllabus, and that we are going to include in our numericals. So in assembly line balancing, first of all, we are going to find out theoretical the number of stations required. Right. So activities will be given to you, and it is assumed that number of machines required to perform these activities or processing are existing on the shop floor. Now we need to make an arrangement in such a way so that you are going to have a least time to perform all the this activities. It means that you need to make an assembly line in such a way so that it is going to be getting balanced, as we know that each and every machines are going to be costing to the company. So if you are making it free for even 1 minute, then also it is going to incur a cost to the company. So as far as possible, we are going to avoid idleness of the machines, and for that we are having some of the methods that is called as a assembly line balancing. So I have mentioned the steps over here, but through the numericals I'm going to make it clear, right? It will be easy for you to understand. So let me directly go to the method. So this is our first method, that is the heuristic method, and in that how we are going to have so if possible, please have a pen and paper with you so that calculations you can do it along with me, right? So first of all, we have to find out the theoretical number of stations required, right?
हेलो मैम
हाँ, am I audible?
आप आपने स्लाइड चेंज किया है क्या
Change दिख नहीं रहे हैं. I have
नो
right
मैम
now. Right now I have on my slide example. Is it visible?
मैम असेंबली लाइन रूल्स में दिख रहा है मेरे को
Example नहीं,
Yes,
example
ma'am.
वाला slide is visible?
No, ma'am. नहीं, ma'am.
Okay, so let me share the entire screen then instead of, just a minute, hold on. Now the Teams is visible to you?
Yes, ma'am.
Okay, so in Teams now I have opened this um, module number 5, facility layout and line balancing. Can you see the example written on my slide?
Yes, ma'am.
Everyone can see the slide?
यस मैम
Okay, now this example is visible on a full screen.
Yes, ma'am.
Okay, ठीक है. Lohit and remaining students, Pratik, is it visible?
यस मैम
Yes.
Okay, so now let me start. Now you people need to do it with me because the same example, I'm taking only one example and explaining you all the methods. So please note down the datas, given data, right, briefly. So here a small electrical appliances is to be produced on a single model assembly line. The work content of assembling the product has been reduced to the work element listed in the table given below along with the information. If possible for you, just add those who are entering into the team. I have given access to everyone. Okay, take it. So the data is mentioned in the table below along with the other information also, right? Now here, the line is to be balanced for an annual demand of 1 lakh of units. So capital D demand is given here as 1 lakh of units per year. Okay. Next is the line will be operated 50 weeks per year. Next data given is 5 shifts per week and 7.5 hours per shift. So we need to multiply all these and convert these data into number of hours available. That is 7.5 into 5 into 50. So total time available to produce this 1 lakhs of units will be in terms of the hours, right? Okay. Next is manning level will be 1 worker per station. So whatever number of stations we are going to decide, so per station only one person is going to be, one worker is going to be available. So we need to concentrate over here. The very first thing is, as far as possible, don't make any machine idle. So we are going to balance it, as well as here it is mentioned that on one workstations, one worker is available. So for worker also we are paying salary, right? So as far as possible, try to avoid idleness of worker as well. Okay, now next, the previous experience suggests that the uptime efficiency for the line will be 96 percentage. So here efficiency of the line, that is belonging to the workstations, are 96%, and repositioning time lost per cycle will be 0.08 minute. It means that whenever a one cycle is going to be completed, again next cycle, before performing or going to proceed for the next line, for the setting up of all the machines as well as job, we are requiring 0.08 minutes. So this 0.08 minute is not going to be considered in the manufacturing time. So now this much data we are having along with the table, which is in next slide. So here we need to determine total work content time, how much time is going to be required to perform this particular project or number of operations, right? And how many workstations are going to be required. Required hourly production rate. So hourly, how many units are going to be produced to satisfy the annual demand. Next is cycle time. Next is theoretical minimum number of workstations required on the line. And the last one is service time TS, to which the line must be balanced. Right. So here in terms of the other data, in terms of the tabular form, the data, remaining data has been mentioned over here. So you can see this. So work element descriptions are given. So this is a type of activity or process which we are going to perform on the machines. This is the tech time. So processing time is this much. And here also we need to proceed with the network diagram, because many activities must be satisfied or performed before proceeding to the next activity. So activity which are going to be preceded by are also mentioned in the column number 3. So this is the data given to us. Now, one request from my end is that this PDF I have already forwarded to you. So to refer the data better, you have to know, with you the PDF, so that it will be easy for you to calculate the required data. Okay. So now let me go ahead with this. Next slide. So as I told you that before proceeding, you need to construct the network diagram. So whatever data is given, activity, predecessor, and durations given to us, on the basis of that, here I have prepared the network diagram. So for 1 and 2, we don't have any preceding activity. So we are starting this activity simultaneously. And proceeding further, activity 3 is uh, uh, this succeeded by activity number 1. So we have drawn an arrow over here from 1 to 3. And above the nodes, this circle is called as a node. So above the nodes, I have mentioned the duration required to perform this particular activity. Am I clear to you? Are you able to construct this network diagram? Anyone? Please respond.
Yes,
Yes,
ma'am.
ma'am.
Okay, okay. Now, what is been asked to you that determine the work content time. So, summation of the duration of all these activities. See, to produce a single product, this many activities are going to be required. So, unless and until all these activities are going to be completed, you cannot have the finished product, right? One finished product. So to to produce one single product, these many activities are going to be performed, and summation of the processing time or duration is nothing but your work content time. So for single product production, you will be requiring 4 minutes, right? Okay. So WTC we have calculated over here as the 4 minutes. Now the other things given over here, let's go ahead with this. So 4 minutes we are having summation of the time of all the activities, that is 4 minutes. So that is our work content time. Now next it has been asked that hourly production rate, right? So as I told you that number of hours available to produce that particular number of units. So data given is in terms of 50 weeks, 5 days working per week, and 7.5 per shift, right? So these many number of hours are going to be available with us. 50 multiplied by 5 multiplied by 7.5. If you are going to divide 1 lakh unit with this amount, then you'll be having 53.33 units per hour. So in hour, you will be able to produce 53.33. If you have a target of 1 lakh of units in year, you need to produce 53.33 units per hour. So this is our second calculations, determination of production rate, hourly production rate. The next one is the cycle time, right? So here we are going to include the efficiency as well. Now see, the production rate is given in terms of hours over here. So we need to calculate the cycle time in terms of minutes. Why? Because these are number of units produced per hour. And usually if the units are given in terms of production rate of hour, then cycle time has to be in terms of a minute, right? So TC is given over here as we have converted hours into minutes. So 60 multiplied by the efficiency is given to you, divided by your production rate, hourly production rate. So you will be calculating these things, then cycle time will be determined as 1.08 minutes. Am I clear with this? Should I repeat it once again?
Excuse me, ma'am.
Yeah.
मैम ये में टोटल वर्क डन इन कंटेंट ये 4 मिनट्स का कैसे आएगा, आप वापस बोल सकते हो? लाइक
जितनी भी एक्टिविटीज हमारे पास थी ना, उनका समेशन करो ड्यूरेशन का. इफ यू कैन सी द कर्सर, ड्यूरेशन इज गिवन एज वी नो दैट वी नीड टू कंप्लीट ऑल द एक्टिविटीज टू प्रोड्यूस सिंगल यूनिट ऑफ प्रोडक्ट, राइट? सो if you are going to make a summation of all these activity duration of all the activities, you'll be getting 4.0 minutes over here at the lowest row. If you can see, is it visible to you?
नो
Yes, ma'am.
Is it visible to you now?
यस मैम, यस मैम.
Okay. So 4 minutes are going to be consumed to produce single unit of a product, right? So here work
Yes, ma'am.
content time is your 4 minutes. So here we have a summation of all these activities. We'll be getting TWC is equal to 4 minutes. Now hourly production rate means demand divided by a number of hours required, or we are having that, so we have divided. So production rate in terms of units per hour is calculated over here in terms of 53.33 units. Next is the cycle time. So this is the equation of cycle time. If efficiency is given to you and your production rate is in terms of hours, then we need to convert it in terms of minutes. So here 60 is multiplied for the conversion of hour into minutes, multiplied by the efficiency given, divided by the production rate. So you'll be getting your cycle time as 1.08 minute. Okay. Now, next one is the theoretical minimum number of workstations required. Sometimes it is asked in terms of a workstation, sometimes it is asked in terms of a number of workers. So equation is both same for both the calculations. So here TWC divided by TC, it means your total work content time divided by your cycle time. So you'll be getting exactly 3.7, but we can't have 3.7 worker or 3.7 workstation. So we are equivalent taking it in the whole figure, that is the 4. So here minimum 4 number of workers or workstations are going to be required in the single line. Next one is the average service time against which the line must be balanced. Now, as I mentioned in my previous slides, that setting time is 0.08 minute, if you remember. Okay, and if you have a PDF with you, then you can just go through the data given. There it is mentioned that 0.08 minutes are required to proceed for the fresh slot of the product. That is for the new unit of product. So here we are going to deduct it from the cycle time. Then we'll be getting 1.08 minus 0.08. So your actual cycle time will be 1.00 minutes over here. Am I clear with this? The data given?
Yes, ma'am.
Okay. So your actually available cycle time is the 1.00 minute. So in 1.00 minute, you need to complete the 1 unit of productions. Right. So theoretically, we have found out over here that in one workstation, the unit of product should not spend more than 1 minute. साइकिल टाइम का मतलब क्या होता है, जो भी कोई वर्क स्टेशन रहता है, सो वहां पे आप 1 मिनट से ज्यादा उस प्रोडक्ट को जो अंडर प्रोसेस है उसको आप रोक नहीं सकते. अगर 1 मिनट से ज्यादा वो रुका, then the whole assembly line is going to be disturbed and your production or target which it is given in terms of a demand, that cannot be satisfied. So you must need to consider this cycle time whenever you are designing or calculating the number of workstations. So this is heuristics. In heuristic approach, we are considering completely the equations and data given to us. Now, in rest of the methods, practically we are going to identify that actually how many number of workstations are going to be required. Theoretically, we have found out over here number of workstations are 4, and your cycle, we need to adhere to this cycle time as 1 minute. Okay, so considering these two datas, we are going to proceed further with the next method, that is called as the largest candidate rule. The steps I have mentioned over here, so just go through it. Hold a minute to stop over here and continuing once again with the same slide.